Hello guys, this is the first video that we will be working together on how to use AI and LangChain to have a very simple workflow and use case to help us analyze window event log. So what exactly is a LangChain, right? So LangChain itself is an open source framework designed to build application powered by the large language model. One of the models, of course, is the OpenAI ChatGPT models. However, there are other supported models that we can utilize via the library as well. So actually to do this, we would need actual window event log or at least crafted scenario that we can use to utilize the AI use case. So Hack the Box has one actually very good platform for us to use for the defense sort of a challenge, and it's called Sherlock. So over here you can see over my screen is the pages for the Sherlock challenge, and one of the machine is called the crown jewel 2.zip. For the next step, we are going to look at the crown jewel 2.zip file. So if you look over to here, you can see that there's a download file. Let's just click on it to download the files. Once this has been downloaded, to open it, you would need the password for the zip file, which is hackable. So let's do that. I have already unzip it earlier, so you can do it on your own. And you can see that there is actually three files over here that's of the window event logs file type. So system security application. I do believe that you will be utilizing all three of them to actually solve the questions over here. For the window event log, if you click directly open it with a notepad, something like that, you will not be able to see any kind of things because it's a binary format. So we would need the actual window event log functions within window to actually open it up. So by default, I have already linked it up so you can see over here. If not, you can just search from your computer to see how to open that. So let's open up the system file. Okay, right now we have a open up the system log file under the event viewer, and we have quite a bit of details over here, things that we can look out for to solve the question. So in this case, there are a few important things like the date and time, the source, as well as the event ID itself. But how do we know which event ID to look out for and exactly what is the timing that we should be looking out for? So I think that is based on the question. One way that we can use to solve this kind of CTF is, of course, to utilize ChatGPT or to utilize some AI for the starting point to start off with. So let's try that out. If we look into the hack the box, this is the questions that they are asking us. So let's copy over this to put it out into ChatGPT to see what is the first things that we can get from here. Okay. So there are some things that they really told us to do, which have we actually have done this part, right? And the next part is followed by the filter events by the service control manager's event ID 7036 and search for any entries related to VSS or shadow copy service. So let's try that out. So I think under the 13529 PM entry, we can see that there is the volume shadow copy service enter the running state. So definitely, we know that this will be the correct answer if we input the date and time stamp into the question. So that's the way to get it in sort of semi-manual way of using the AI. However, we want to go one step above that to see how we can use LangChain to automate this process so that we can have a good AI use case. So for the next part, we will be looking at how can we actually input this window event log into the LangChain framework, right? But before we start, let's try to understand the data format for this window event log better. If we go into the details, we can see that there's some binary data as well as most of it is categorized in XML format over here. So I think one of the easier way to work with structured data, right, is of course to convert into a format that is easily available for all type of usage. And one such format is of course a JSON format, right? So my ideas is that let's transform this event log into a JSON format and before ingesting into the LangChain to have a more structured way of doing things. So let's try to do that for this part. We will be using the Google Colab to demonstrate most of our use case. Reason is that it's quite easy to set up this Jupyter notebook within the browser and for us to have easy access and easier time to demonstrate some of the code to you. I would also encourage you to have some Python understanding as well before going deeper into the course because we will be actually working with a lot of Python code on how to actually convert the window event log format to JSON. So to start off, we can actually just run a command line in Google Colab very easy by actually have an exclamation mark behind followed by the command that you want to run. So in this example, just the present working directory to see where are we working on. So we are working on the content path itself. And for the next part, let's try to install some mandatory library for us to do the parsing. So two of the library, one of the libraries the XML JSON and the Python window event log library. So let's install that. Once it's done, will be the main code over here and the main function to convert the XML to JSON format by inputting the event log into the script itself. However, don't be too intimidated by the code over here or things like that because this is something that is searchable within the GitHub repo. You can take a look itself and I will copy the link for you to see as well later. What we really need to understand is that you just need to provide the path to the window event log out. Then after that, when we run the script, it will automatically convert into a JSON format. So that is something that we just want to do. And so to start off, let's actually move the window event log, a system log, into the present working directory and for the script to convert it. Let's do that. So yes, we are looking for the system file and let's list it out. Yes, we can see the system file is here, .evtx file. So once it's here, let's just or start the function. Oh, that's because we haven't run this part yet. Let's try it. Okay. So right now we see that the output has been saved to a file called JSON system.json and let's get it out. Okay. Right now we can see that this has been successfully converted into a JSON format. So for us to use with LangChain data. So before we can actually start using LangChain as a framework to analyze window event log, we need to be installing some prerequisite library and set up the environment before we can start. So I will first introduce you to some of the common libraries that we'll be working with within the LangChain so that you can use it for your own project next time. So to move forward, for first part is of course the LangChain community version. This is the main library that we are working with a lot of the functions there that can help us achieve the very simple work case or use case for this AI example. The next part is definitely the LangChain and the Open AI library integration. This provide you the functions to work with the OpenAI if you are using OpenAI. So in other case, of course, let's say they are using DeepSeek in your application, then you'll be looking at the LangChain DeepSeek library to work with that. Moving on, we have the LangGraph. So LangGraph is a relatively new way of writing LangChain application because it's more of a graphical way of writing the application design so that you can manage it in multi-agent scenario that are stateful. So for this part, we will be going through some example when we are working with the LangChain agent to see how we can make use of LangGraph to do that. For the tick token, A tick token itself is more like a library to optimize the token that we are using or for the token limit. This is also important when we are trying to chunk document into small chunks or before we are passing on to the applications or before we are passing on to the AI model. These help us to save costs and is one of the important aspects of the AI management. For the LangChain hub, it's more like a place where you can use or like a repository that you can use to get front template. That's one example of how you can use the LangChain hub. Also, LangChain hub has a lot of that you can also pull from to actually help with your AI application. And the other part, this is one of the more important part, is the Chroma DB. Chroma DB itself is like a database meant for AI application. So the difference with this and a traditional database is the way that the data is being stored. So for the Chroma DB, is actually storing all this information that we have or data that we have into a vector. So then after that, it will be used to retrieve from the database based on the vector itself. So I think it would be easier if, of course, you see it in action, and this is something that you just want to take note of, and probably do a more in-depth research on what is a vector database. And lastly, we have the JQ. JQ is a powerful command line JSON processor for us to handle JSON file, and it help us to actually pass some of the output into something that we want to use before we put it into the application. So roughly, that's about all the libraries that we will be using with. And the other very important part for us is to actually set up the environment, which is the API. So if you look at the code over here that we are working with is actually with OpenAI. So I will assume that you already have a OpenAI account and the API setup. So I will show you in the next part how to do that. So after we are done with the installations for all the required libraries, we will be looking into creating the environments variables for our LangChain application. So we would need the OpenAI API key as well as the LangChain API key. So these both of the API key that we need. For the OpenAI API key, you can actually go into your OpenAI profile, and under the profile section, you can find the section where you can create the secret key over here. So just create it and give it a name, and you can use the secret key as the variables for your web application. So as for the next part for the LangChain, or rather the LangSmith, this is the API key that you need to put in, and you can find over here under your LangChain or smith.langchain.com URL. What LangSmith does is that it's actually a verbose feedback for the applications, whereby you can see what is being passed on to the models and what is being exchanged out from the models. This helps us to actually have a lot of understanding on what is happening in the backend for the LangChain. So after you are done with the installations of the required libraries and also the generation of your API key, you can just put the API key values over here for your OpenAI and the LangChain API key values here for the LangChain LangSmith. The other two part is creating a kind of like a project name to use within the LangChain LangSmith. So you can actually put your own project name as well, and it helps us to categorize it better and to look for the logs better. Inside the next part, we will be importing the OS module, and from the OS module, we'll also be importing the load.env functions, which will help us to load the env files into the environment. So by running this, we can see that this gives us a true response. Uh, for the next part, right, the start of any Python application will be importing the libraries. So there's a few important libraries that we'll be working with, and one of it is the document loader libraries. So within the document loaders library, we'll be importing the JSON loader because this is the part that we are working with mostly. Because we converted the window event log into JSON format, that's why we are using the JSON loader right now. So you can see the way to call the JSON file is to specify it under the kind of the parameters that we have. So our file is called system.json, right? So let's make sure that this file is actually in the same file path as the application. To do that, you can just go to your Google Colab and go to your, let me see, okay, users, oh, okay, content, right? So you can go to the content sections over here, and this will be the place where your web application is stored. So just kind of like right click and upload your system.json that we have converted earlier into this place as well to make sure that it's able to find the file. For the next part, we will be using the JQ schema to actually load the JSON file. What JQ schema does over here is to specify which data fields that we want to be included into the JSON. This is actually very important in our application because the more specified you are in giving the JQ schema in relate to your questions that you're asking the AI models, the better the answer will be. So in the first example, since that we won't be knowing exactly what we want to find right now, so I will just load everything without any filtering. So to load everything without any filtering, you can follow this syntax, a dot with open bracket and close bracket. So we will use the text content equal to false, and that's all you have to do for now. So let's try that. And once that it has run successfully, we will try to see if there's anything within the document object after loading it. We see that there's a 208 object, and let's try to print out the first object that we see. So for the first object, you can see that is in the correct JSON format, and there are certain things that, or at least there are a lot of data types or data fields that is being passed. And of the more important one, of course, is the event ID, as well as the strings that we can see that tell us what is going on with the event. So with that, that form the basis of how we are going to work with the LangChain to help us get the answer we want. But before that, we have to actually create the ChromaDB object. For the reason for why we need the ChromaDB object instead of putting the whole JSON response into the model, that's because if you try to put that, most of the time you will find that you will hit the token limit. And this is the reason why we have the DB, or at least that help us to solve a lot of the problems by actually calling out the most similar response or the most correct response before actually putting it into the AI model. So this is actually what it does in the full sense, right? So in this case, there are a lot of ways to actually chunk or at least data fields into the DB itself. For now, I will not be using the recursive JSON splitter. I will be just putting the whole things inside. So the reason we do that is that I don't want the JSON response to have any kind of overlapping, so that we can have more accurate data coming out for now. So to set up the DB object, you just need to enter a few important fields. First is the document, which is we putting in the same name. So that's why you see the documents equal documents. That's the parameter. And this is actually the variable name. So embedding itself, we are using OpenAI embedding. There are many different type of embedding method that we want to use. So far, we just I will not go too in depth into that. For now, you can just use the OpenAI embeddings, but just to keep a note that there are other embedding method as well. And for the collection name is we're going to name it as system/chroma. So let's create that. Okay, now that is done, you will have the retrieval object right here. So let's see that what the name or what are the things that's being created inside this DB. So within the DB, right, we can see that it's being categorized at each of the items has IDs over here. So right now, every single one of them has ID, and within that, there is the data fields. So this is how it looks like. Okay. So for the next function, I created this function just in case that we need to delete the database for testing purpose before we do anything. So you can use this to delete, but for now we don't need to use this. Okay, here's the more interesting part, right? So this is the that we write our application most of the time by having first the template. The template, you can think of it as a system prompt. When you have a system prompt, you are just telling the AI or at least the models or the AI applications that you are trying to achieve something and you give him the background context of it. So this is how it looks like. So in this case, we are a cybersecurity window event log helper, which help to identify malicious event and answer the question based only on the following JSON context. Take note of the bold instruction, explain why you choose this answer. Example, this is called bold, right? So this is the latest, tell you to take note of it. The square, the bracket over here, the curly bracket over here, which is the context, right? The context is actually what is stored inside the Chroma database. So we'll be retrieving from the Chroma database, get the most similar answer before actually putting it over here into the context and link it up with the questions. So this is how it looks like when it's finally passed on to the model. So the next part is the prompt. The prompt itself, we are using the chat prompt template from LangChain and to create prompt. And the model itself is the chat open AI models. We'll set certain parameters like the temperatures, 0, you want to be as accurate as possible, less imaginative. And for the models, we'll be using the GPT-4o model. So after the model here, we have the next part, which is the LCEL, standing for LangChain Expression Language. This is a user-friendly way to define LM workflow without writing extensive Python code. You can see from the first part over here, this is actually the first input to the chain, represented by the dictionary with two key value pair. The key value pair over here you can see is the context and the question. The value inside first for the context is the retrieval that belongs to actually the first part that we created on the Chroma DB. Second thing, for the questions itself, we are actually using a LangChain utility called the runnable pass-through, so that within our template over here, the questions, we are putting the questions directly into this input. For the next part, we are using the pipe. You can see this, the pipe sign. Actually, pipe connect different components into the chain object. So from here, the input, we are passing it directly into the prompt. And after that, we get the model, which we already defined earlier, which the chat OpenAI model with a temperature of 0. With the model, we are using the GPT-4o. And after that, finally, we are actually piping into the string output parser. So again, this is a LCEL utility function useful for extracting and formatting the model response to a string. And when we are done with the whole thing, this whole chunk of code over here would be the chain itself, which is the LLM chain. And the last ingredient that we need before we can actually get the output would be the query. So the query, what I use over here is the actually from the HTTP, which is the first part of the question, which is over here that you can see. So it's asking the questions whereby where is the timing exactly that they are using, the service is using the Microsoft Shadow Copy service, and what is the most recent timestamp at which the service entered the running state. So I put the questions over here. The only difference is that sometime when we are working with a large language model, for to get a certain output that we want, uh, the questions and the language and the tonality of how we ask the questions sometimes makes a lot of difference in the output. This is why that sometimes it's very difficult to get consistent output from a large language model. You have to go by trial and error to see how can you rephrase your question sometimes to get a more consistent output. So by trial and error, I think I just kind of like added certain changes to specify what timestamp do I want, and that actually helped me to get a better result. So we can see over here. Uh, the chain has been done, and based on what it says, the latest timestamp when Microsoft software shadow copy provider service is being run, this is at 053955. So let's see if this is the correct timestamp that we can input into the questions itself. So let's try that. Okay, so the ChatGPT, uh, the AI model has successfully actually get the timing for the Microsoft Shadow Copy services correctly.